morning. This lesson is for my Honors Integrated 1. This is lesson 3.3. But before I get started, I want to say I hope everybody is doing okay out there. So let's just go ahead and jump right into our lesson. We have two goals today. Our first goal is to define what we call function notation. And our second goal is to use a table to create a linear function. And remember, a function is a relation where each input has one output. Not unique, but each input has an output. I said unique in an earlier lesson, that was wrong. It's each input has an output. All right. Each input only has one output. Sorry, let me clarify that again. So in our first goal, defining function notation, this right here is called f of x. And this is function notation. So whenever you see this, you know that you have function notation. And basically, f of x is another way to write y. And remember, y is our dependent variable. And so I wonder if you can figure out what word I'm writing here. I'll give you a second. Really? Yes. So instead of y being the output, we're going to use f of x. And I want to explain really quick why this is useful. And I have the same linear function written twice, once with y and once with f of x. So here I worked out the y equals 2x plus 3. I let x equal 5. I plugged in 5. X could be any number. I just picked a number at random, worked it out, and I know that y equals 13. So now I'm going to do the same problem, but I'm going to use function notation. And wherever I have an x, like in here, I've turned it into a 5. But when I'm using function notation, not only do I have an x in the function, but I have it in the function notation. So it should be written as f of 5 equals 2 times 5 plus 3. And then 2 times 5 gives me 10, plus 3, that gives me 13. And I know that f of 5 is equal to 13, as opposed to y equals 13. Now, why this is valuable, and we'll see here in a minute, is remember, functions are relations, and relations are a set of ordered pairs, meaning that I plug in an x and I get a y back. So if we were to just, say walking down the street, and we come across y equals 13, all that we can say from this bit of information is that the ordered pair has a y value of 13. Do I know what the x value is that got me this 13? No, I do not. However, in the function notation, remember it's f of x, but in this case x is 5, and when I plug in 5, my entire y value is 13. So I get some more information from function notation. Later on, when you guys get to higher level mathematics, we use function notation to tell you what to plug in. And so it's a way to communicate inputs. It's also a nicer way to know what you plugged in and know what you got back. So it's a more descriptive way to write functions. So right now, this is all we really need to know. Is it tells us who is plugged in and what we got in return. This is my input. This is my output. This whole f of 5 is my y, even though it doesn't look like a y. This whole thing is y, and inside there's my x. So again, you can make ordered pairs from function notation. I'm going to check off the first goal, and I'm going to move on to my second goal. And my second goal, again, is to use a table to create a linear function. Now, I want to just kind of tell a story about my construction project that I'm doing, because it's really actually relevant to creating linear functions from a table, and it gives you an idea of how to set this up. So I'm finding that as I hire contractors, they have a certain fee structure. Like they charge you just to show up, and then they charge you by the hour or by the day. All right. So, for example, my plumber. If I call my plumber out to come work on my project to set the sewer lines or the water lines or the gas lines, the way that he charges me is he charges me $90 just to show up. That's a flat fee, $90 just to get there. And then after that, he charges me $60 an hour, right? So imagine getting paid just to show up. But that fee structure also makes sense because, you know, if the plumber's there for less than an hour, he's guaranteed $90. Anything beyond that, he's just adding $60 an hour. So in my example, I am talking about my personal experience that my plumber charges $90 to show up, and then $50 an hour after the first hour. And here I wrote the independent and dependent. It's very important to understand who's controlling what, right? And so there's two concepts here. There's how much I'm paying and how long my plumber's been there. And one is controlling the other. So is how long my plumber's been there control how much I'm paying, or is how much I'm paying control how long my plumber's been there? And they both can both kind of work, where I might just say I only have a certain amount of money, this is how long you can work, but you don't want that to be the case when you're building something new. You want to be able to cover the entire cost. So the independent variable in this situation is the time, right? And that means that the amount of time that my plumber is at my project, that's going to control how much this is going to cost me, or I'm going to have to pay my plumber. Now, again, I said I want to use a table to create a linear function. So what I'm going to do is I want to have a little bit extra space, so I'm going to erase this over here, so that I can have a lot of room. So if I was to ask you to figure out, make me a table and figure out how much this is going to cost me, what you guys would probably do, first of all, you'd probably write X, and you'd want to start to write Y, but then you'd realize, oh wait, I need to use function notation, so I'm going to use this. Remember, this is my Y value, okay? And you might have a little trouble picking this first value. And so the question I would ask you would be, how old are you when you're born? And you would say that you're 0. So if I asked you, how many hours has the plumber worked when he showed up? The answer is 0. So for the plumber to show up, my time starts at 0. All right, and when my plumber shows up, it costs me $90. And so then the next thing you would say is, well, after the first hour, it's 90 and 50, so that's going to be 140. And then after the second hour, I'm going to add another 50, so that's 190. And then after the third hour, I'm going to add another 50, so I'm up to 240. And so you would continue this. Now, the problem with the way that you're doing this, and I see this a lot, is you're putting the numbers together and you're not creating a pattern. We want to find a pattern, but if you put numbers together, there's no pattern to be had. And so I want to show you how we're going to create a pattern based on this situation, because if we can create a pattern, we can create a linear function. So the best way to create a pattern is not to put the numbers together. All right, so let me try and show you what I mean. Okay, so if I was trying to create a linear function representing the cost of having a plumber come out for for a certain number of hours. Here's what I would do. I know that it's going to cost him $90. Cost me, not him. He's going to make $90. It's going to cost me $90 for my plumber to show up. The first hour, or at the beginning of the first hour, it's $90 plus 50. My next hour would be $90 plus 50 plus 50. I'm going to put a little bit of a gap here. My next amount of time, my next bump in cost would be 90 plus 50 plus 50 plus 50. And every time I add a new row, I add a new 50. So here I have one row on my first hour, or after my first hour, I have 150. After my second hour, I have 250. After my third hour, I have 350. Now, we can actually simplify this. Notice that 50 plus 50, that's the same as 90 plus 50 times 2. And here, instead of saying 50 plus 50 plus 50, I could actually say this is 90 plus 50 times 3. And I can start writing my rows like this. So after the fourth hour, actually that would be the fifth hour, and I'll talk about that later, but this we could write it in a shorter way. This would be 90 plus 50 times 4. And hopefully you're recognizing that this number is exactly the same as that number. And it's happening on every row. And it doesn't look like it's happening on the first row, but it actually is happening because there's a 1 there. And in fact, it's also happening on the very first row. So the pattern that we're seeing here is that we're multiplying the number 50, oh, that's 50, no, we're multiplying the number 50 by the number in our x column. So if I want to, and this is what we do, and this is actually going to finish the first or the second goal, is we want to extend this pattern to some unknown amount of time, which we call x hours, because we don't know how long they're going to be around. But we know that if they're there for 4 hours, it's 90 plus 50 times 4. After the fourth hour, I should say. After the fourth hour. So we're actually getting into the 5th hour here. All right. Okay. So right here, this line is going to be 90 plus 50 times x. And so I would not have found this if I just put the numbers together. You want to keep the numbers separate. You want to break them up so you can create the pattern, because once you see the pattern, once I see repeating numbers, once I see my repeating numbers, once I see my repeating numbers, once I see my repeating numbers, I have gotten to the point where I have used a table to create a linear function. And my linear function for this situation, where my independent variable is time, my dependent variable is cost, is going to be f of x is equal to 90 plus 50x, where x is the time value. I plug in any value for x, I calculate that out, and whatever answer I get after I plug in my amount of time my plumber's there, that's going to equal the cost of my plumber doing the work. So this lesson that you're going to be doing in the homework, again, you have to know how to use a function notation. It's a goofy way to write y. But you're also going to be asked to create linear functions. I find that students have a lot more success if we make the table. The table's going to be the key. So it's going to take a little bit of practice to get used to writing the table, but I think that if we get this down, we will be able to start to tinker with these, what we call indexes. And I will hold off on the comment I wanted to make because I don't want to add any confusion to this. But just remember, we start with 0. Because how old are you when you're born? You're 0. All right, so this concludes the lesson. Again, I hope everyone's doing all right. Have a good day. I will see you guys later. Bye-bye.